welcome back. This is Professor Ridge, and today's lesson 3.7, Determinants and Cramer's Rule. So first, let's start off with what a determinant is. So we'll start off with 2 by 2 determinants. Okay, so the determinant of a 2 by 2 matrix, A, B, C, D, with the brackets here, that's for matrix. You denote it with these straight bars, like the absolute value symbol, okay? And it's defined to be so here's the technique. You're going to multiply along the diagonals, A times B, or A times D, minus, and then go along the other diagonal, B times C. Okay, so just pretty straightforward. It's just that formula. We want to make sure we know that. So it's a way to get some kind of like size, a number for matrices. So I'm going to evaluate. I can ask you to find the determinant or evaluate. And so this just gives you a number. Now with the brackets, a matrix is that object. It's an array of numbers. So it's not really a number that we can add, subtract, multiply, divide per se. But when you put the straight bars, that's the determinant of the matrix, and that gives you a number. And the way you calculate the number is you go 2 times 9, so along that, we call that the main diagonal, minus, and then you go 4 times negative 5. And then just do the, using order operations, just evaluate that. 18 minus, well that's plus 20, which is 38. So the determinant of that matrix is 38. And that's all you do. Okay, let's look at example 8, or exercise 8 from the book. Again, we're going to evaluate this matrix, so we're going to go 3 times negative 3 minus 2 times 2. Remember, we're going down the diagonals. Like that. So we get negative 9 minus 4, which is negative 13. Okay, so that's a 2 by 2 matrix. Alright, so now for a 3 by 3 matrix, the 3 by 3 determinant, so the determinant of a 3 by 3 matrix can be defined as follows. And notice that I'm just using subscripts. A is the first column, and A sub 1 would be first row, first column. A sub 2, first row, second column. A sub 3 would be first row, third column. We can define it by, this is called expansion by minors. So I can take that first column, A1, and if you imagine crossing out the first column and first row, what's left over is B2, C2, B3, C3. So you take that 2, so we're going to do A1 times the, what's the 2 by 2 matrix, we call that the minor actually. So again, if you took A1, B1, C1, A2, A3, B2, C2, B3, C3, and so if I'm using A1, I'm going to cross out the row, the column, and then what's left over, that goes there. Then we're going to go minus, and we're going to go A2. We're going to cross out the row and column for A2 and write what's left over. So let's see if we have A1, B1, C1, A2, B2, C2, A3, B3, C3, and we cross out the row, the column. What's left over is going to go in this matrix. B1, C1, B3, C3. Plus, now we do A3, and then the same idea. If you cross out the row and column for A3, whatever is left over, we call that the minor. And we put it to the determinant of that minor. So I'm going to cross out A3, row, column, and then what's left over goes up here. So it's B1, C1, B2, C2. So this is the definition of a 3 by 3. It's not the only way to do it, but that's the way we're going to define it. Alright, let's try an example. Okay, so we're going to evaluate the determinant of this 3 by 3 matrix, and we're going to expand by that first column. You can actually do it by column or row. So you're going to take the first number times the minor. Remember, the minor is if we cross out the row and the column. You can't see what I'm doing, but if I put my finger or a pencil over the first row and then the column that I have circled, we just ignore that. And what's left over, and we're reading columns, so I got the 2, 4, and the -1, -3. And then it's always minus the second number in the first column times what's left over. So again, if you could if you have like an extra pencil, put extra pencil in your offhand and cover up the second row and ignore the row the column that I circled, the 2, 1, 3. Cover up the middle row and then just write what's left over. So if I go -1, 4, 1, -3. And then plus the third number, which is 3, and again cover up the third row and ignore the first column and just write what's left over. So -1, 2, 1, -1. And then we're going to go 2. Now using how we define to do a 2 by 2 matrix, it's going to be 2 times -3 minus 4 times -1. Okay, so that's the first one. The middle one is going to be -1 times -3 minus 1 times 4. And normally I would just write the answer down instead of doing this, but for the notes I just want to show you all the calculations. -1 times -1 minus 2 times 1. So we're going to get 2 times -6 plus 4 minus 1 times 3 minus 4 plus 3 times 1 minus 2. Okay, I'm doing order operations, that's all, nothing too extravagant. So do inside the parentheses, -1, and then the last parenthesis is also -1. Now multiply, so it's -4 plus 1 minus 3, which is -4 plus 1 minus 3 is -6. Okay, and normally I don't show all that work at all. I mean, I would probably go right to here for my first step, and then from there I would skip the step, and then I would go to that step. Okay, so I would skip those two that I didn't put the arrow by. I just wanted to show you all the calculations though. Alright, so that's a 3 by 3. So how do we go back to systems? How do we solve a system using determinants? Well, this mathematician, last name's Cramer, came up with this idea of, okay, the way I can use determinants to solve a system Okay, so Cramer came up with the rule. So the solution of the system, a1 x plus b1 y equals c sub 1. So notice the subscripts is for equation 1, and then the second equation, the subscripts are 2's. So a sub 2 x plus b sub 2 y equals c sub 2. And the way you do this is x is going to be equal to, now the top is going to be, well, first let's start with the bottom. The bottom is going to be just the coefficients, a1, a2, b1, b2. So that's for both x and y. So that's the same answer on the bottom. Okay, so we call those are the coefficient matrix. The determinant of the coefficient matrix. Remember, the matrix is with the brackets. The straight bars are determinants, which we evaluate and get a number for it. Now the top is going to be the coefficient matrix, but when you're solving for x, you're going to take the x column out and replace the x column with the constants. So instead of putting a1, a2, you're going to put whatever the number is on the other side of the equal sign, c1, c2. Now for y, the top again is the coefficient matrix, but I'm going to take the y column out and replace it with the constants. So the c1, c2 go in the y column. And that's it. Now when I do a 3 by 3 matrix, if you understood the words I just said, you can extend it to 3 by 3, and the bottom will be the coefficient matrix. And for x, the top will be on the coefficient matrix, but you replace the a's, the x column, with the constants. And then for y, you replace the y column with the constants. And if you're in 3 variables, then you do it for the z. Same thing. You're going to take the z column out and replace it with the constants. So I'll show you in a second. We'll write it down. Alright, so let's try this. Let's solve number 17. So I got 5x plus 8y equals 1, 3x plus 7y equals 5. So again, x is going to be the coefficient matrix on bottom, so x's are 5 and 3, y's are 8 and 7. The top row, I'm going to take the a column out, the x column out, sorry, and I'm going to replace it with the c's, 1, 5. But the y's stay the same. Now I calculate that, so that's going to be 1 times 7 minus 5 times 8 over, and then do the bottom, 5 times 7 minus 3 times 8. So our operations, do the 7 minus 40, which is negative 33. And on the bottom, we get 35 minus 24, which is 11. So x must be 3. Negative 3. Now we're going to do y. Let's start y over here so we don't run out of room. The bottom's the coefficient matrix, which I don't have to do any work for the bottom. I already know the bottom is 11. Now the top, I'm going to leave the x column alone I'm going to take the y column out. I'm going to take the 8, 7 out and replace it with the y's. With the constants. Those are the constants. So now the top is going to be 25, 5 times 5, minus 3 times 1, which is 25 minus 3, which is 22 over 11, which is 2. So now my solution is the point -3, 2. Okay, so that's Cramer's rule for 2 by 2 systems. Now note, if the denominator the determinant on the bottom equals 0, the coefficient matrix, then it's one of the special cases. You can't use Cramer's rule. Well, I guess you could. If the top number, if the top number is 0, like you get 0 over 0 on both of them, then it's dependent, and you have an infinite number of solutions. So that's dependent. If the bottom is 0 and you get a number over 0, then that's no solution. Okay, so those are the special cases. But other than that, you get the one solution. So as long as the bottom's not 0, you can get the answer. If you get 0 over 0, then it's dependent, which is an infinite number of solutions. If you get a number over 0, then it's no solution. All right, let's try the 3 by 3s now. Okay, so using Cramer's rule for a 3 by 3 system, what you do, and notice, all the subscripts, equation 1, equation 2, equation 3. So A is for x, and A sub 1 is the coefficient of x in the first equation. B sub 2 is coefficient of y in the first equation. So C sub 3 is your coefficient for z in the third equation. All right, so that's just a good way to distinguish them, so we don't have A, B, C, D, E, F, G, H. So it's a little easier to do it this way. Now I want to emphasize the words that I used in the other one so you don't get overwhelmed. Notice that D is just the coefficient matrix. The determinant of the coefficient matrix. Okay? Now D sub x is the coefficient matrix, and notice I intentionally left the first column blank because I want to emphasize you're going to replace, for solving for x, you're going to replace x column with constants, with the constants. So the constants would be d1, d2, d3. So what do you think dy is? And notice I left the middle column blank because you're going to replace the y column with the constants. So we're going to put b1, b2, d sub 3. And then for d sub z, again, I'm going to replace the z column with the constants. But notice all the other numbers are the same. So A is the x column, B's is the y column. I'm going to take the z column out and replace it with constants, d1, d2, d sub 3. Now, a couple ways you can do it. You can work these out, all four of them, and then these are not the solutions. Remember, the solution for Cramer's rule is the determinant d sub x divided by d. To figure out y, it's going to be the d sub y divided by d. And then for z, you're going to do d sub z divided by d. So you can write it out and put the matrices here and here, or you can write them out separately like I did above and work them out individually and then plug in the numbers and do whatever the number is for d sub x divided by d. And then for y, d sub y divided by d, so on. Alright, let's try it. Okay, so we'll do the, number 24. And so D is going to be the coefficient matrix. 1, 1, 2, negative 1, 2, 1. And Z's are 2, 3, 1. So I'm just taking the coefficients. And again, it has to be X, Y, Z. So I'm going to work that out. I'll probably do that in scratch work. I'm going to do d sub x. So I'm going to take the x column out, leave the other two columns alone. I'm going to take the x column out and put in the constants, which is negative 3, 4, negative 3. And I'll work that one out. Again, I'll just do it on scratch paper. And then your challenge is see if you can do it yourself too and get the same answer I do. D sub y, again I'm going to leave the first column alone. Second column I'm going to put the constants, so I'm going to leave it blank for right now just to emphasize. Z. So d sub y, I'm going to take the middle column out, the negative 1, 2, 1, and replace it with the constants, which is negative 3, 4, 3. And again, I'm going to do this on scratch work in a minute. And you'll see the numbers magically appear, because I'm going to do it on pause, so you don't have to wait for me to figure them out. But I would suggest you do the same, see if you can calculate it on your own. D sub z is, we're going to leave the first two columns of D alone, the coefficients, and take the Z column out and put in the constants, which is negative 3, 4, negative 3. And again, I'll work this out on scratch paper. Okay, so I don't know if you caught that, but I think I had a positive 3 there, so that should be negative 3. Alright, so doing on scratch work, D, you should get negative 12. D sub x, you should get 36. D sub y, you get negative 24. And D sub z, you get negative 12. Now, if you have a graphing calculator, they have menus where you can plug these numbers in and calculate them quite easily. However, you won't be able to use it on the final, so make sure you can calculate it with just a normal calculator, scientific calculator. But anyway, so with this method, and especially if you could use technology, this is a great way to solve. Alright, so we're not done. We just figured out the four matrices. Now, x is d sub x divided by d, which we just found d is negative 12. D sub x is 36, so x is negative 3. Y is d sub y over d. D sub y is negative 24. D is negative 12, so that's 2. And z is d sub z over d, which is negative 12 over negative 12, which is 1. So our solution set is negative 3, 2, 1, and you can check it. So I challenge you to try to figure out the four matrices, determinants, D, D sub x, D sub y, D sub z. Do it calculating on your own just to see, or at least do one or two of them, just to make sure you got the hang of it. Alright, so that concludes the lesson for 3.7, Cramer's Rule and Determinants. And go to My Math Lab, complete the exercises there, and I will see you next time.